Lesson 9.9, volumes of rectangular prisms. What is another good word? What would be a common term for a rectangular prism? What's it look like? A cube would be one type, but what? Oh, right. What would you say that is? Does it look like a box? It looks like a box, right? A box. Okay, so listen, it's pretty simple. I'm going to show you how to find volume. Volume is how much, see, if I was to ask what's the distance between me and Sladen, the answer would be something in feet, right? It would be like a certain amount of feet or a certain amount of inches. It's a distance. If I was to ask you how much area is there in this room, we're talking about how much carpet would fit in this room. Does that make sense? How much carpet would it take to fill this room? And that would be, how would you answer that? Something in squared feet, right? 1 by 1 squares, or squared yards or squared inches, but it would be something squared. Do we all agree? Are we all following me here? Are you all following me? So between me and Sladen is a distance. That's just feet. If I was to ask you how much carpet or what's the area in this room, it would be squared feet. How many 1 by 1 square piece of carpet does it take to fill this room? Volume is how much air is in this room. How much air is in the room. In other words, how many 1 by 1 by 1 boxes are there? How many 1 by 1 by 1 foot boxes or 1 centimeter boxes or 1 inch box or 1 yard box is there? Does that make sense? And so you'd have to start envisioning and go, okay, I put a little 1 by 1 foot box over there in the corner and start stacking them up. And then start stacking them up. And how many would there be in this room? Well, it would be a lot. I mean, it would be a lot of them. Here's the way you figure out volume of rectangular prisms. It's how you find the volume of any object, but I'm going to show you how to do it with a rectangular prism. Let's just take a plain old square or a rectangle to start. Okay, there's our rectangle. When I do this and I go, okay, this is 6 inches. We'll say feet. We'll make it easy. 6 feet, and this is 10 feet. Can you tell me the area of this object? You should be able to. What is it? 60 squared feet, right? It would be 60 squared feet. Okay. Let's say that I took that 60 square feet. Okay, 60 square feet. It's a piece of paper, we'll say, like this is 60 square feet, okay? Just like the box I have up there. And I put it on the bottom. Okay, I set it down on the bottom. And I'm going to make a box. I'm going to make a box now with this being the bottom. Or this being what's the name for the bottom? What's the name for the bottom? The base, right? I'm going to make this be the base of my object. So here's my 60 square feet, and I'm going to put it as the base. So watch this. Now, so here's the deal. If that's true, then that means that this is 10 feet and this is 6 feet. Does that make sense? I've taken that object that we had. It was 10 feet by 6 feet, remember? And I put it as the bottom. And now it's the base of my now three-dimensional object. And I told you that the height was 5 feet. This is what you need to be able to envision, okay? I'm going to do something for you here. I'm going to do this. Just wait. Just give me a second here. I'm going to do something. I'm just going to grab... Do you see what I just grabbed? Do you see what I just drew down here at the bottom? It's just the very bottom foot. So then this is now 1 foot. This is 6 feet. And this is 10 feet. Do you see what I'm talking about? I want to do something here. Okay, do you see what I'm talking about? Can you tell me how many, just in this bottom part here, how many cubes are there? How many 1 by 1 foot boxes are there in this? How many, in just this bottom part, and just that, how many of these 1 by 1 foot boxes are there? You should be able to tell based on the information I've given you. How many are there? There's 60, right? There's 60 of them down there. Well, what if it was 5 feet tall? So then what would I do? If the bottom layer is 60, then how many more layers do I have to do? How many more layers? 4 more layers, right? So if the bottom one's 60, then the next one is 60, and the next one's 60, and so it's 60 times 5. 60 times 5, right? There's 5 layers, it's 60 times 5, which would make it 300 cubic feet. Notice that I do cubic. That 3 means cubic, it means cubes, right? It means 1 by 1 by 1. That's how you say volume. In this room here, in this room, let's just say that it is, well, I'll draw our little, do you agree that that looks like a good representation of this room? In fact, it's probably not, it's probably a little shorter and fatter than that. So hold on, we'll say it's a little shorter. Here's our room. Okay, here's our room. And I would say that for real, this is probably 40 feet by 30 feet. So 40 feet this way, 30 feet this way. And then how tall do you think that ceiling is? If I'm 6 foot,
Like
12, right? Twice as high tall as I am. So 12 feet. Let's envision it. How do I figure out the volume? What do I do? I need to find the bottom floor, just the bottom 1 by 1 foot area, right? So then how would I find just the bottom part? Wouldn't it be 40 times 30? Wouldn't it be 40 feet times 30 feet? And that's how big the bottom would be? What's 40 times 30? 1,200. Now what do I do with that? That's just the bottom foot. That's just that would be how many of these 1 by 1 foot squares are here? Now I have to do what to find the whole volume of this whole room? Multiply it by how many? 12. There's 12 feet tall, right? So times that by 12. What is 12 times 12 is 144. So 144,000. That would be 14,400 cubic feet in here. It would take 14,400 of these 1 by 1 by 1 foot blocks to put in this room. That's a lot, right? So how, rather than for me to draw this every time and do this every time, do you see what the formula is going to be?
Yes.
What's it going to be? Length times width times height, right? That's one way of doing it, is length times width times height. Length, width, height. The actual formula looks like this. I'm going to show you this. The actual formula says the volume equals capital B H. Do you remember what is the area of a parallelogram? Is base times height, but it's a small b. Do you remember that? The area of a parallelogram is small b times small h. Small b meaning that it's just the base of the two-dimensional object, right? The base of this right here. Does that make sense? That's why it's small b. Why? How can volume be? Why? What is capital B? What do you think that means? Nope. Look. Here's my object. Here's my height. Do you agree that that's the height? Do you agree that h up there is the height? Do you all see that and agree? Do you see it? And yes, that is true. That h is the height. Are we all paying attention to me? So then what do they mean by capital B? How is it base times height? It is base times height, but why is there a capital B?
Because it's the square base.
It's the area. It's the area of the base. Does that make sense? It's the whole base. It's all of this. It's that whole thing. Whatever the area of the whole base is, times the height. Remember how when we had our this right here, well, let's go back even further. Let's go back to the one before this. There. How do we figure this one out? What do we do? What did we do? We broke it up how? What did we find first?
Base.
We found that guy, right? And that was the what? That was the area of the base, right? That was the area of the base. 10 times 6. And we found out that the base was 60. Right? Squared feet. And then we multiplied that so that this right here, this 60 squared feet is capital B. That's the area of the base. Then what do we do with it once we got done with that? Multiplied it by the height. So then the volume is capital B times the height. That's how you find volume. The reason why I showed you all that is just so that you can know that it's this. Volume equals capital B times H, or volume equals, what's the other way of writing this? Length times width times height. Does that make sense? What is length times width, people?
Base.
That's the base, right? That would be the base of the rectangular prism. Let's do a couple of these. Let's do a couple. Tell me number, I'll give you one. Let's give you one. That's a horrific drawing. I'm going to do a much better job. Okay, that's 2, 3, and 10. I want you to tell me what is the volume. Tell me what the volume is. Does it take any work at all here?
No.
I would like you to tell me then really quick, tell me what capital B is. What's the base? What do they mean by what is the base? So tell me the answer. What is the base? 30. The base is 30 squared centimeters, right? The base is 30 squared centimeters. So what's the height? 2 squared centimeters. So then what is the volume here, Sladen? Cubic centimeters. And you actually just go like this. You would say it like this. That is 60 cubic centimeters. Make sense? Yes. You could say centimeters cubed or, whatever. But it's the proper lingo is cubic centimeters. What about this? They give you some questions that look like this. Oops. I would like you to tell me, we'll say that this right here will go like this. Tell me the volume of that object, please. All right, so here's the deal. What do I need to know? What do I need to know to find the answer to this? Can you almost, listen, can you actually see this? Could you almost count this?
Yeah.
Could you almost count them? You know what I mean? Like actually go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could. You could almost count them. You know what I mean? It might take you a little bit, but you could do it. What do I need to know? Tell me what I need to know.
The base.
Ellie, what do I need to know? How many is the base? Or what is the dimensions of the base? 6 and 4. 6 and 4. That means at the bottom, even though I didn't show you the back, can you envision it? Can you see it, right? So it's 6 times 4, so the base is 24. There's actually 24 cubic feet on the base. Do you see what I'm talking about? And then, so then what do I do now? What do I do at this point, Sladen? Multiply by the height, right? How many of these bases are there? How many of these sets of blocks are there? Well, there's 3. So times 3. What is 24 times 3? 72 cubic feet. How many of you have 72 cubic feet? Right? Good. Not difficult. It's just going to take you some, It's going to take some thinking. A lot of times they don't do that for you. They don't, and oops. They don't give it to you in blocks. They just go, this is 5, 4, and 8 centimeters, centimeters, centimeters. And even though you know what to do with the math, can you at least envision it? Can you at least envision what this is? If this is 5, then it's going to go like this, right? Right? And this is going to be like this. Do you see what I'm talking about? And it's going to go like this. And, you don't need to do that every time, but can you at least envision it? You see what I'm talking about? Can you envision it and go, oh, it's just the same thing. It's just I need to find out the base, the number of blocks on the bottom, and then how many sets high is it? It's the same thing. They just didn't do all that for you. They just told you it's 5 by 4 by 8. What's the shortcut for doing this? What do you do? 5 times 4 times 8? Right? 160 cubic centimeters is the volume. Okay. I'll give you your homework. Page 459 to 460. 3 through 10, 3 through 10 even, and 16 to 21.